Hi, last class we have discussed about covalent bond and its different types of bonding dependent on the number of shared pair of electrons. So in this class we shall be discussing about polar covalent and non-polar covalent bonds. So what are polar covalent and what are non-polar covalent? We'll be detailing discussing the definition and few examples. So before we go back, let's just take a recapitulation of what is a covalent bond. How do we define a covalent bond? So covalent bond is nothing but it's a bond formed by mutual sharing of electrons between the two atoms. So both the atoms will share the electrons mutually to form a covalent bond. So now after sharing the electrons between the atoms, what happens for the cause of a polar and a non-polar covalent bond? So after they share the electrons mutually, the tendency of pulling the shared pair of electron towards itself is the major factor which causes polar and non-polar covalent. So now let's see what is a polar covalent bond. Polar covalent bond can be defined as a type of chemical bond where the pair of electrons which is being shared is unequally shared. So after they get mutually shared, it's a natural tendency that the shared pair of electrons should be at the center. But what happens due to the presence of an electronegative atom, the shared pair of electrons will be pulled towards the electronegative atom. So let's take a look at the example, that is HF. So here we have two atoms, one is hydrogen and fluorine. Out of these, fluorine is highly electronegative. So what does the fluorine do? It will slightly pull the shared pair of electrons towards itself. Then the tendency of pulling will be more for fluorine compared to hydrogen. So hydrogen cannot revert it. Finally, when we look at the fluorine atom, we feel the rich in the electron cloud. So there will be a slight bulge of electron cloud. So therefore, what we can see in the picture is, we can see this bulge nature on fluorine, indicating that there is a more number of electrons on fluorine compared to hydrogen. So that causes the polarities. So now let's take a look at what are non-polar covalent bond. So non-polar covalent bond can be defined as a chemical bond which occurs between the two atoms and the shared pair of electron is at equidistance or is at equal distance between the two atoms. So whatever the electrons are shared, they will be present at the center or at equal distance between the two atoms who are sharing the electrons. For example, I have taken the example of a simple hydrogen. So in hydrogen, both are hydrogen atoms, so they do not have the tendency of pulling the electrons much more. The electronegativity is equal, so it's the same atom, so therefore they will be at the center. So you can have non-polar covalent bonds with dissimilar atoms. So dissimilar atoms, for example, you can have one as nitrogen and something else as hydrogen also. So let's discuss it a little later. Now let's just take a look at this orbital structures of water and hydrogen. So water is an example of polar covalent and hydrogen is an example of non-polar covalent. So in this, we can clearly see there is a more number of electrons. So the electron cloud is little huge on oxygen, and oxygen has a tendency of attracting the shared pair of electrons. So therefore, whatever was the equidistance of electrons between oxygen and hydrogen, they would have moved towards the oxygen, making sure that the oxygen becomes slightly bulky. Whereas in case of hydrogen, they are same atoms, so therefore they do have the electronegativity difference is zero. So they will not have the difference of pulling the electrons. They pull them with equal force. So therefore the shared pair of electron will be exactly at the center. Now let's see what are the conditions for the formation of a covalent bond. So all of them will have certain conditions for the formation. The first and foremost condition is any two atoms who are involved in the bond formation should have more than 4 valence electrons in their shells. So when I say valence electrons, it is the outermost electrons, or you can also call it as more than 4 electrons in their outermost shell. For example, this is usually our non-metals which have this tendency of having the more than 4 electrons in the valence shell. So then what happens is they cannot afford to lose so many electrons because they're very close to the octet. So natural tendency is that they would try to share their electrons and try to form a covalent bond. So that is the first condition for us. They should have more than 4 electrons in the outermost shell. And the second important condition is those elements or any one of those atoms who are involved in the bond formation should have high electronegativity. Now, before we go into that high electronegativity, what do we mean by electronegativity? So, as we all of us know that electronegativity is just the tendency of attracting the shared pair of electron towards itself. So when a bond is formed, any one atom who is electronegative, it's just a tendency of that particular atom to pull the shared pair of electrons. So when the electronegativity difference is high, the shared pair of electrons will be attracted. So therefore what happens, the tendency of the bond formation will be more and the attraction force is more, so the electrons will be tightly folded. The second next condition is high electron affinity. Now what do we mean by electron affinity? Electron affinity is nothing but some amount of energy released when an electron is added to an atom. So when we try adding an electron to an atom, the atom intact gives us the energy back. So that amount of energy is called as the electron affinity, because the atom would have attracted the electron. I mean, we are forcing an electron inside and that atom requires an electron to become stable. So therefore it gives us the energy back. So when this value of electron affinity is high, then the tendency of accepting the electron is more, because they will have high nuclear charge and they will attract the new electron also, like the one which was there with them. So the next condition is the atoms should have high ionization energy. Now what is ionization energy? Ionization energy is nothing but the minimum amount of energy required for an atom to remove an electron. It's a minimum amount of energy required for an atom to remove an electron out. Now that minimum amount of energy should be very high. It indicates that whatever atom is involved in the bond formation should have high ionization energy. That means it should not be ready to lose electrons. If it readily loses electrons, then the ionization energy will be low. But here our condition says ionization energy should be high. So that means it's not ready to give out any electron. So then we can get to know that the attraction force or the nuclear charge is very huge. So therefore it accepts a new electron and even holds the new electrons tightly. And the last condition is the electronegativity difference between the two combining atoms. So when we have two atoms we are trying to combine, can be either zero or negligible, or it can be a little more difference. So depending on their electronegativity difference, we can also talk about what type of bond would be formed. So we will do a little later about the last point. So these are the general conditions for the covalent bond formation. Now let's take a look at the examples. So these are the few examples of polar covalent bonds. So we clearly know the examples which are stated are very easy. That is your HCl, H2, and NH3. So in this case, let's take the example of one and go through it little elaborately. The same concept goes for water as well as for nitrogen, I mean the ammonia. So here you can see there are more electrons present on this atoms which have got the delta negative sign. So that means they're slightly negative because they have more number of electrons. Here also we have our oxygen atom which is electronegative. Similarly here when you look at the nitrogen, you can see the negativity of nitrogen, or there is more number of electrons, hence you get a delta negative. So now let's take HCl in detail and look at how it becomes a polar covalent bond. So all of us know HCl is a compound which is very simply formed by a covalent bond, because hydrogen just has 1 electrons and chlorine has 7 electrons in its valence shell. So the tendency is hydrogen needs 1, chlorine needs 1. So both of them are not in a state of losing or gaining. So the major or the second thing what they can do is share the electron. So they would share one electron each and they would tend to form a bond. Now the bond formed here is a covalent bond. This is what is the definition we have learned. Now how does this covalent bond get transferred or get transformed into a polar? So why does the polarity come? So here you can clearly see this electronegative chlorine atom. So the electronegativity is also given by, we all follow Pauling scale. So in that, fluorine is the highest valued electronegative atom. Fluorine has the numerical value as 4 for electronegativity. The chlorine is the next one which has the second highest electronegative atom, that is its value is 3. When you compare this with hydrogen, hydrogen just have an electronegativity value as 2.1. So therefore there is a quite more difference, that is about 0.9 difference is there numerically, and the tendency of attracting the shared pair of electron is more for chlorine because its electronegativity value is high compared to hydrogen. So they would have shared their electrons like this, and it was supposed to be at equal distance. But due to the presence of this chlorine, which is actually more having a greater tendency to attract the shared pair of electron, or you can say it is just greedy enough to pull the shared pair of electrons towards itself. So therefore, the polarity will be more for chlorine. So as this gets the electronegativity value as 3, so slightly this shared pair of electron gets moved from the center towards chlorine. So when one electron, both electrons were here, when both the electrons goes towards one particular atom, the electron density on that atom will appear to be more. So you should have a clarity here. The electron is not transferred. It's not completely out of hydrogen. It is just with the hydrogen. Instead of being at the center, it's just drifted towards the electronegative atom. When it is drifted, we feel that the chlorine has a huge number of electron density. So therefore, it gets a slight negative charge. So it's a slight negative charge. So this chlorine, the electron cloud is more and the mass of the chlorine is also more. So slightly you develop a delta negative here. This is the symbol used for showing our polarity. So this is the delta, and negative indicates that it's rich with electrons. Whereas hydrogen obviously gets a delta positive because it does not have so much of electrons like chlorine. So after this positivity and the negativity occurs, then we call this type of a bond as polar covalent bond. So polar indicates there is a polarity. Now what is polarity? Polarity is nothing but a positive and a negative charge. So you should just have 2 poles. So we have got 2 poles. One is a positive pole and a negative pole. So all the polar covalent bonds are because of the presence of electronegative atom, or we can also convert the definition as there would be a little more or a little difference in electronegativity. So when there is a difference of electronegativity is absolutely 0, you get your non-polar. When the electronegativity difference is a little, then you get your polar covalent bond. So now let's take a look at our non-polar. A simple example. This is an example of non-polar covalent, which is made up of similar atoms. So I think we are very clear about hydrogen. So it has one electron. They would have shared the electrons and form a bond. Since both of them are hydrogen atoms, the electronegativity difference is 0 because same atoms, so they try to pull equally with the same force. So hence it is an example of a non-polar covalent bond. So this is the shared pair of electrons which is circled, as you can see here. So they would be present at equal distance between the atoms. So the distance is from this center point till here. So the same things. Now let's take another example of nitrogen, which is also made up of similar atoms. So it's again an example of non-polar covalent. This has 3 electrons which is shared. So how do we get to know the number of electrons shared will be just 3 or 2? Because nitrogen has 5 electrons in its valence shell. And when it has 5 electrons in the valence shell, our target is to become 8. So I got 5, I need another 3 more. So where is this 3 more coming from? These 5 electrons, the 3 electrons will be shared from the 5. So that's how we get to know what is the number of electrons supposed to be shared. So here you get 3 electrons which will be shared from each nitrogen atom, and then they tend to form a covalent bond, which is non-polar because their electronegativity difference is 0. Or you can say because they are the same type of atoms and they pull with same force. So this is our shared pair of electrons, which is again present at an equidistance. They would have overlap and it is at equal distance between both the atoms. So now let's take another example of dissimilar atoms. That means it's not the same atoms which are involved in the bond formation. It's a 2 different atoms. So it's a combination of 2 atoms. So we have taken an example of CCl4, that is your carbon tetrachloride. So we have 1 carbon and 4 chlorines involved in the bond formation. So here you can see a carbon, 4 valence electrons. So this carbon, to become stable, it needs another 4 atoms or 4 electrons. So chlorine, I think we are pretty sure that chlorine just can accept 1 electron or can share 1 electron. So therefore, we need 4 chlorine atoms so that it can satisfy 4 valence electrons of the carbon. So they tend to form a bond, and then this is how the bond sharing will happen. It's a single covalent bond. Now, after being a single bond here, since all the 4 corners, we have 4 chlorine atoms, so it's going to get nullified. So whatever is the force of the chlorine pulling the electrons upward, the same force will be available at the back downwards. So this gets, all the forces gets into, you talk about your vector quantities. So when the direction is there, this is in the forward direction, this is in the backward direction, again this is for towards your left and this is towards your right. So finally the whole atom gets cancelled all the charges and they will become a neutral, or they will become a non-polar. Another way of talking about this, you can talk about with their electronegativity difference. If the electronegativity difference is less than 0.4, it is a non-polar covalent bond. So now let's see what is the difference between the polar and non-polar covalent bonds. So the difference, we will take a few differences. The first and foremost difference is how is the shared pair of electron. So the pair of electrons which is shared is actually not equal in case of a polar. So it's not shared equally because one atom will be electronegative and it will pull the electron towards itself. So in case of non-polar, it is equally shared. So, or the shared pair of electron is at the center or at equidistance. That is what we mean when we say with the word equality. Now, when we talk about the difference in electronegativity. So when it is a polar covalent bond, so they will have a small difference in electronegativity. So that small difference is a little difference which we are talking about that causes the polarity. When you absolutely have a 0 difference or it is quite negligible. So the negligible factor which we are talking about, will be doing it a little later, that is it can be less than 0.4. Then it would become non-polar covalent bond. And these polar covalent bond, as you clearly know, they get the polarities, that is nothing but the charges. So the charges can be separated here. So when you add this polar covalent bonds into a water or into an aqueous solution, they get ionized. So they get ionized in water, and this process is called as ionization. Therefore, we call our polar covalent bonds can ionize in water. All this factor happens because of the presence of the charge. If charge is not there, then they do not get ionized in water. So that is what will happen to our non-polar. So non-polar does not have any charge. It doesn't have any slight positive or slight negative. So therefore it does not get ionized in water. So these are the important differences between our polar and non-polar covalent compounds. Now let's take a look at, all the time I was telling you we'll take a look at this just little later. So this is what I was talking all about. When we are talking about electronegativity difference, there will be a slight confusion in the mind because we are using the word zero, negligible, little, more. So what is this all about? When we get a numerical value, we get a perfect clarity in the mind. So that is what is this diagram representing all about. So when I say negligible, so when the difference between the electronegativity atom will be below 0.4, the difference should be below 0.4, then it would result in the formation of non-polar covalent bond. So if it is 0 till 0.4, it is a non-polar bond. So when it goes above 0.4 till 1.7, we are talking about the difference. So this is what being is shown here as delta En. Delta N is small difference in the electronegativity. So the electronegativity difference when it is in the period of 0.4 to 1.7, then that atom will be polar in nature. So this is what we were using a word called as little difference. So that little difference is numerically 0.4 to 1.7. So what happens to the bonds or what happens to the atoms when they have En difference more than 1.7? So when they are going to be above 1.7, they mostly turn out to be an ionic bond. So you have a larger difference in the electronegativity, so then they would tend to form an ionic bond. So the nature will be ionic in nature. So now I think we get a little better clarity between these words zero, negligible, little. So that is what is this all about. That is your difference in the electronegativity scale. So this helps us to find out what type of bond is there. So we have come to the end of the session. So let's take a look at the points what we have discussed. So we have learned about what is a covalent bond and what is polar covalent and non-polar covalent, the reason for the formation of polar and non-polar covalent bonds. And we have learned about the conditions. So all the conditions, all the 5 points which we have discussed, it's nothing but you should have high electronegativity, high electron affinity, high ionization energy. The valence electrons are supposed to be more than 4 and the electronegativity difference should be 0 or negligible or little. Then we have learned a few examples of polar and non-polar covalent compounds and the differences between the polar and non-polar covalent compounds. So that's what we have done in today's session. So hope it's very clear, and we have done about few more molecules. That's your similar and dissimilar non-polar covalent. So this is what we have learned in this session. Thank you.